Now let us move on to the first question in the exercise. A path in the shape of a quadrilateral ABCD has angle C is equal to 90 degrees, AB is equal to 9 meters, BC is equal to 12 meters, CD is equal to 5 meters and AD is equal to 8 meters. How much area does it occupy? Now let's move on to the solution. We shall first consider a quadrilateral. So let us name the quadrilateral A, B, C and D. Given AB is equal to 9 meters, BC is equal to 12 meters, CD is equal to 5 meters, AD is equal to 8 meters. And also angle C is equal to 90 degrees. So now let us draw the diagonal BD. Now since in the given question angle C is equal to 90 degrees, therefore triangle BCD is a right angle triangle. Therefore, the side BD is obtained using the Pythagoras theorem, which is hypotenuse square, that is BD whole square, is equal to side square, that is BC whole square, plus side square, that is CD whole square. Therefore, BD whole square is equal to BC square, that is 12 whole square, plus CD square, that is 5 whole square. 12 square is equal to 144 plus 5 square is 25. This gives BD square is equal to 169. This implies BD is equal to 13 meters. So now we have BD is equal to 13 meters. Now we shall find the area of triangle BCD. The area of triangle BCD can be found using the formula half into base into height. Since triangle BCD is a right angle triangle, therefore area of triangle BCD is equal to half into base is 12 meters into height is 5 meters. So 2 goes in 12 6 times. Area of triangle BCD is equal to 6 meters times 5 meters, which is 30 meters square. Now we shall find the area of triangle ABD according to Heron's formula. So area of the triangle ABD is given by square root of S times S minus A times S minus B times S minus C, where A, B, C are sides of the triangle and S is equal to the semi-perimeter, that is A plus B plus C divided by 2. Here in triangle ABD, let A is equal to 9 meters, B is equal to 13 meters and C is equal to 8 meters. Therefore, we can find the semi-perimeter S, that is 9 meters plus 8 meters plus 13 meters divided by 2, which is equal to 30 divided by 2, that is equal to 15 meters. Now we shall substitute the value of S in the formula for area of triangle ABD, that is equal to square root of S times S minus A times S minus B times S minus C. which is equal to square root of 15 times 15 minus 9 times 15 minus 13 times 15 minus 8, which is equal to square root of 15 times 6 times 2 times 7, which is equal to square root of 15 can be written as 3 times 5 times 6 can be written as 2 times 3 times 2 times 7. Since 3 times 3 is 3 square and 2 times 2 is 2 square, so we can bring out 3 times 2 from the square root and we are left over with square root of 5 times 7. So which is equal to 6 times square root of 35 meter square. So we have found out the area of triangle BCD and area of triangle ABD. To get the area of the quadrilateral ABCD, so we add the area of triangle BCD and area of triangle ABC, as the diagonal of the quadrilateral BD divides ABCD into two triangles. So therefore area of quadrilateral ABCD is equal to area of triangle BCD, that is 30 meter square, plus area of triangle ABC, that is 6 root 35 meter square. So which is equal to 30 plus 6 times square root of 35 is 5.91, which is equal to 65.46 meter square. So this is approximately 65.5 meter square. Therefore area of quadrilateral ABCD is equal to 6.5. Area of quadrilateral ABCD is equal to 65.5 meter square. Now let us move on to the second question. So find the area of a quadrilateral ABCD in which AB is equal to 3 centimeters, BC is equal to 4 centimeters, CD is equal to 4 centimeters, DA is equal to 5 centimeters and AC is equal to 5 centimeters. So let's move on to the solution. So we shall first consider a quadrilateral. So now we shall name the quadrilateral, that is A, B, C and D. So given in the question, AB is equal to 3 centimeters, BC is equal to 4 centimeters, CD is equal to 4 centimeters and AD is equal to 5 centimeters. Also given AC is equal to 5 centimeters, which is the diagonal of the quadrilateral ABCD. So now we need to find area of quadrilateral ABCD. As we know, the diagonal AC divides the quadrilateral ABCD into two triangles. Those are triangle ABC and triangle ACD. Area of quadrilateral ABCD is equal to area of triangle ABC plus area of triangle ACD. So now let us first find area of triangle ABC. So according to Heron's formula, area of triangle ABC can be given by square root of S times S minus A times s minus b times s minus c. Here A, B and C are sides of the triangle and S is equal to semi-perimeter, which is A plus B plus C divided by 2. So in the area, in the triangle ABC, the sides are 3 centimeters, 4 centimeters and 5 centimeters. Therefore, let A is equal to 3 centimeters, B is equal to 4 centimeters and C is equal to 5 centimeters. So now we shall find the semi-perimeter S, which is equal to 3 plus 4 plus 5 divided by 2, which is 12 divided by 2, that is 6 centimeters. So now we shall substitute the value of S in the formula for area of triangle ABC, which is equal to square root of S times S minus A times S minus B times S minus C, which is equal to square root of 6 times 6 minus 3 times 6 minus 4 times 6 minus 5, which is equal to square root of 6 times 3 times 2 times 1, which is equal to square root of 6 times 6. 6 times 6 is 6 square. So we have square root of 6 square is 6. Therefore, area of triangle ABC is equal to 6 centimeters square. Now we shall find the area of the triangle ACD. So according to Heron's formula, area of triangle ACD is given by square root of S times S minus A times S minus B times S minus C. So here A, B and C are sides of the triangle ACD. So A is equal to 4 centimeters, B is equal to 5 centimeters and C is also equal to 5 centimeters. So now let us find the semi-perimeter, that is A plus B plus C by 2, which is equal to 4 plus 5 plus 5 divided by 2. So it is 14 divided by 2, which is equal to 7 centimeters. Now let us substitute the value of S in the formula for the area of triangle ACD. So area of triangle ACD is equal to square root of 7 times 7 minus 4 times 7 minus 5 times 7 minus 5, which is equal to square root of 7 times 3 times 2 times 2. Here 2 times 2 is 2 square. So we can bring out 2 from the square root and we are left over with 2 times square root of 21. So therefore, area of triangle ACD is equal to 2 root 21 centimeter square. Now, area of the quadrilateral ABCD is the sum of area of triangle ACD plus area of triangle ABC, which is equal to 6 centimeter square plus 2 root 21 centimeter square. So this is equal to 6 centimeter square plus 2 times square root of 21 is 4.6 centimeter square. So we have 6 plus 2 times 4.6 centimeter square, which is equal to 15.2 centimeter square. Therefore, area of quadrilateral ABCD is equal to 15.2 centimeter square. Now let us move on to the fourth question. A triangle and a parallelogram have the same base and the same area. If the sides of the triangle are 26 centimeters, 28 centimeters and 30 centimeters and the parallelogram stands on the base 28 centimeters, find the height of the parallelogram. So let's move on to the solution. So now we shall consider a triangle and a parallelogram. So now let us name the triangle as A, B and C, and we'll name the parallelogram as P, Q, R and S. Given that the sides of the triangle are 26 centimeters, 28 centimeters and 30 centimeters. So let AB be 26 centimeters, BC be 28 centimeters and AC be 30 centimeters. And also given that the parallelogram stands on the base 28 centimeters, and let the height of the parallelogram be h, which we have to find. So in the given question, the condition given is area of the triangle is equal to the area of the parallelogram. So which is area of triangle ABC is equal to area of parallelogram PQRS. So now let us find the area of the triangle ABC. So according to Heron's formula, area of triangle ABC is equal to square root of S times S minus A times S minus B times S minus C. Here A, B and C are sides of the triangle and S is a semi-perimeter, which is A plus B plus C divided by 2. Therefore the sides of the triangle are, so let A is equal to 26 centimeters, B is equal to 28 centimeters and C is equal to 30 centimeters. Now we shall find the semi-perimeter S, which is A plus B plus C divided by 2, that is equal to 26 plus 28 plus 30 divided by 2, which is equal to 84 divided by 2. Therefore S is equal to 42 centimeters. Now we shall substitute the value of S in the formula for the area of triangle ABC, which is equal to square root of S times S minus A times S minus B times S minus C, which is equal to square root of 42 times 42 minus 26 times 42 minus 28 times 42 minus 30, which is equal to square root of 42 times 16 times 14 times 12. So which is equal to square root of 42 can be written as 6 times 7, 16 can be written as 16 itself, and 14 is written as 7 times 2 and 12 is written as 6 times 2, which is equal to square root of 6 times 6, 7 times 7, 2 times 2 times 16. So 6 times 6 is 6 square, 7 times 7 is 7 square, 2 times 2 is 2 square. So since all are perfect squares, we shall bring out these terms from the square root. So we have 6 times 7 times 2 times square root of 16 is 4. So which is equal to 336 centimeter square. So therefore area of triangle ABC is equal to 336 centimeter square, which is also equal to area of the parallelogram PQRS. Area of a parallelogram PQRS can be obtained with the formula base into height. So since area of PQRS is 336 centimeter square and base of the, so as given in the question, base of the parallelogram is 28 centimeters and we need to find the height of the parallelogram. So this implies height of the parallelogram is equal to 336 centimeter square divided by 28 centimeters. So 28 goes in 336 12 times, and therefore height of the parallelogram is equal to 12 centimeters. Now let us move on to the fifth question. A rhombus shaped field has green grass for 18 cows to graze. If each side of the rhombus is 30 meters and its longer diagonal is 48 meters, how much area of grass field will each cow be getting? So let's move on to the solution. We shall first consider a rhombus shaped field. We shall first consider a rhombus. So we shall name the rhombus as A, B, C and D. As given in the question, each side of the rhombus is 30 meters and let BD be its longer diagonal and its length is 48 meters. So we need to find area of rhombus shaped field. So to find the area of the field, we shall first find area of triangle BCD. So we can find area of triangle BCD according to Heron's formula. That is, area of triangle BCD is equal to square root of S times S minus A times S minus B times S minus C, where A, B and C are sides of triangle and S is the semi-perimeter, which is equal to A plus B plus C divided by 2. So let A is equal to 30 meters, B is equal to 48 meters and C is equal to 30 meters. So we shall find the semi-perimeter, that is A plus B plus C divided by 2, which is equal to 108 divided by 2, that is 54 centimeters. So now we shall substitute the value of S in the formula for the area of triangle BCD, which is equal to square root of S times S minus A times S minus B times S minus C. So this is equal to square root of 54 times 54 minus 30 times 54 minus 48 times 54 minus 30. So this is equal to square root of 54 times 54 minus 30 is 24 times 54 minus 48 is 6 times 54 minus 30 is 24. This is equal to square root of 54 can be written as 9 times 6 and 24 is written as 24 itself, and 6 and 24 are written as it is. So now 6 times 6 is 6 square, 24 times 24 is 24 square, and 9 is 3 times 3, that is 3 square. So we bring out the perfect squares from the square root. So we are left over with 3 times 6 times 24, which is equal to 432 meter square. Therefore, area of triangle BCD is equal to 432 meter square. So from this, area of the rhombus ABCD is equal to 2 times of area of triangle BCD. Therefore, area of the rhombus ABCD is equal to 2 times of 432 meter square. So which is 864 meter square. So according to the question, the grass in the rhombus shaped field is sufficient for 18 cows to graze. Therefore, area of grass for 18 cows is equal to 864 meter square. So, but area of grass for 1 cow is equal to 864 divided by 18 meter square. 18 goes in 864 48 times. Therefore, area of grass that is sufficient to graze for 1 cow is equal to 48 meter square. Now let us move on to the 6th question. An umbrella is made by stitching 10 triangular pieces of cloth of 2 different colors as shown in the figure, each piece measuring 20 centimeters, 50 centimeters and 50 centimeters. How much cloth of each color is required for the umbrella? So let's move on to the solution. So the umbrella contains 10 triangular pieces of cloth of 2 different colors. Therefore, it contains 5 pieces for each color. We shall first consider one triangle. So let the triangle be ABC. So A, B and C. We shall first find the area of the one triangle, that is ABC considered. So according to Heron's formula, area of triangle ABC is given by square root of S times S minus A times S minus B times S minus C, where A comma B comma C are sides of the triangle and SB is the semiperimeter, which is obtained by A plus B plus C divided by 2. So as given in the question, the sides of the triangle are 20 centimeters, 50 centimeters and 50 centimeters. Therefore, let A is equal to 20 centimeters, B is equal to 50 centimeters, C is equal to 50 centimeters. Now let us find the semiperimeter, which is A plus B plus C divided by 2. So which is 120 divided by 2, that is 60 centimeters. Now we shall substitute the value of S in the formula for the area of triangle. ABC, that is square root of s times s minus a times s minus b times s minus c. This is equal to square root of 60 times 60 minus 20 times 60 minus 50 times 60 minus 50. So this is equal to square root of 60 times 40 times 10 times 40. So this is equal to square root of 60 can be written as 6 times 10 and 40 can be written as 4 times 10 and remain with 10 times 10. So since 10 times 10 is 10 square and 10 times 10 is 10 square, 4 can be written as 2 times 2. So we bring out the perfect squares from the square root. So we are left over with 2 times 10 times 10 times square root of 6. So which is 200 times square root of 6. Therefore, area of one triangle of the umbrella, that is triangle ABC, is equal to 200 times square root of 6 centimeter square. So area of 5 triangles in the umbrella of one color is equal to 5 times 200 root 6 centimeter square, which is 1000 root 6 centimeter square. Hence, the area of the cloth required for each color in the umbrella is 1000 root 6 centimeter square. Now let us move on to the 7th question. A kite in the shape of a square with a diagonal 32 centimeters and an isosceles triangle of base 8 centimeters and sides 6 centimeters each is to be made of 3 different shades as shown in the figure. How much paper of each shade has been used in it? So let's move on to the solution. So we shall consider the figure. Now we shall first name the square A, B, C and D. So we mark the intersection point of the diagonals of the square as P and the smaller triangle as C, E and F. Now given in the question, diagonal of the square is equal to 32 centimeters, that is AC is equal to BD is equal to 32 centimeters. Since diagonals of a square are equal, also AP is equal to PC is equal to 32 divided by 2, that is equal to 16 centimeters. Since diagonals of a square bisect each other, and we also know that diagonals of a square bisect each other at right angles. Therefore, angle APD is equal to 90 degrees, which is also equal to angle CPB. So now we shall consider area of shaded region 1, that is area of triangle ABD. Since it is a right angle triangle, area of triangle ABD can be obtained from the formula half into base into height, which is equal to half into base of the triangle ABD is nothing but the diagonal BD, which is 32 centimeters as given in the question, and height of the triangle ABD is AP, which is half of the diagonal of the square, that is half into 32. So 2 goes in 32 16 times. Therefore, area of the triangle ABD is 256 centimeters square. Now, let us move on to the area of second region. That is area of triangle BCD, which is similar to the area of triangle ABD, as triangle BCD is also a right angle triangle. Therefore, its area can be obtained from the formula half into base into height, which is equal to half into base of triangle BCD is nothing but the diagonal BD, which is 32 centimeters as given in the question, and height of the triangle BCD is PC, which is half of the diagonal AC, that is half into 32. So 2 goes in 32 16 times. Therefore, the area of the triangle BCD is 256 centimeters square. Now we shall move on to the area of third region. So the third region is a triangle and it is isosceles as given in the question. Therefore, area of triangle CEF can be obtained according to Heron's formula. Therefore, area of triangle CEF is equal to square root of s times s minus a times s minus b times s minus c. Here a, b and c are sides of the triangle and s is the semi-perimeter, which is a plus b plus c divided by 2. In the question, the base of the isosceles triangle is given as 8 centimeters and its equal sides are given as 6 centimeters. Therefore, let a is equal to 8 centimeters, b is equal to 6 centimeters and c is equal to 6 centimeters. So now we calculate the semi-perimeter, which is a plus b plus c divided by 2. So this is equal to 20 divided by 2, which is 10 centimeters. Now we substitute the value of s in the formula for the area of triangle CEF, which is square root of s times s minus a times s minus b times s minus c. This is equal to square root of 10 times 10 minus 8 times 10 minus 6 times 10 minus 6. This is equal to square root of 10 times 2 times 4 times 4. So, which is equal to square root of 10 can be written as 2 times 5 times 2 times 4 times 4. This is equal to 2 times 2 is 2 square and 4 times 4 is 4 square. Therefore, we can bring out the perfect squares from the square root. So we are left over with 2 times 4 times square root of 5, which is equal to 8 times root 5 centimeter square. Therefore, area of the third region is equal to 8 square root of 5 centimeter square, which is equal to 8 times square root of 5, that is equal to 17.92 centimeter square. Therefore, the paper required first and second regions is 256 centimeter square, and the paper required for third region is 17.92 centimeter square. Now let us move on to the 8th question. A floral design on a floor is made up of 16 tiles which are triangular. The sides of the triangle are 9 centimeters, 28 centimeters and 35 centimeters as shown in the figure. Find the cost of polishing the tiles at the rate of 50 paisa per centimeter square. So let's move on to the solution. So given in the figure is the floral design containing 16 tiles which are triangular. So we shall first consider one triangle. So let this be one triangle out of the 16 triangular pieces of tiles. So we shall name this triangle A, B and C. As given in the figure, AB is 9 centimeters, BC is 28 centimeters and AC is 35 centimeters. So now we shall first find the area of triangle ABC. According to Heron's formula, area of triangle ABC is equal to square root of S times S minus A times S minus B times S minus C. Here A, B, C are sides of the triangle and S is a semi-perimeter which is calculated by A plus B plus C divided by 2. So from the figure, the sides of the triangle are A is equal to 9 centimeters, B is equal to 28 centimeters and C is equal to 35 centimeters. Now let us find the semi-perimeter which is A plus B plus C divided by 2, that is equal to 9 plus 28 plus 35 divided by 2, which is equal to 36 centimeters. Now we shall substitute the value of S in the formula for the area of triangle ABC, that is equal to square root of S times S minus A times S minus B times S minus C. So this is equal to square root of (36 times 36 minus 9 times 36 minus 28 times 36 minus 35. So this is equal to square root of 36 times 27 times 8 times 1. So this is equal to square root of 36 times 27 is written as 3 times 9 and 8 is written as 4 times 2. So this is equal to 6 times 3 times 2 times root 6, which is 36 root 6 centimeter square. Therefore, the area of one triangular tile of the design is equal to 36 root 6 centimeter square. Therefore, the area of 16 such tiles is equal to 16 times 36 root 6 centimeter square, which is equal to 576 root 6 centimeter square. Given in the question, cost of painting the tiles per centimeter square is equal to 50 paisa, that is equal to 0.5 rupees. Therefore, cost of painting the tiles per 576 root 6 centimeter square is equal to 0.5 times 576 root 6, which is equal to rupees 288 times root 6, which is equal to rupees 705.60.